Okay, I prepared 3 homework problems from section 2.1. Let's look at number 8, 9, and 10 together. So number 8, a particular country's exports of goods are increasing exponentially. Oh, that's a great news. The value of the exports T years after 2005. So, okay, so T is 0. So for year 2005, T is 0, right? But year 2006, which is 1 year after 2005, T is 1. So if you want to find T, just do the year minus 2005. Okay, so dot, dot, dot. All right, what do they want? So they're giving us a model, V of T, the value given time T is equal to 1.4 times e raised to the 0.039 t, where t equals 0 corresponds to 2005. A, we already kind of talked about that. And V is in billions of dollars. Okay, billions of dollars. So we will remember that unit. After getting the value, we will make sure to multiply by billion, or we can just write down it's billions of dollars. But let's see what we're doing here. Part A, estimate the value of the country's exports in 2005 and 2010. Okay, so for 2005, just find V of 0, right? Because 2005 is our base year. So all I need to do is plug in 0 into the function. 1.4 times e raised to the 0.039 times 0. We don't need a calculator for this because anything to the 0 power, hold on, this entire thing, that is just 1. This is just 1. This is 1 because e raised to the 0 power, anything raised to the 0 power is just 1. So in 2005, the value of the country's export was 1.4 billions of dollars. I'll just go ahead and draw the dollar symbol. Okay, how about for 2010? All right, I need to find T first. T is equal to 2010 minus 2005. And that is 5 years later, right? So we need to find V of 5. Yeah, 5. V of 5. So you will do 1.4 times e to the 0.039 times 5. And for this, I need a calculator. So I'm gonna go ahead and type this in. I'll do 1.4 times e to the 0.039 times 5. Wow, it went up to 1.7 billions of dollars. Billions of dollars. It increased, huh? Okay. So what's the last part? What is the doubling time for the value of the country's export? Remember we had that formula up here. We have the doubling time formula up here. Ta-da! This pink one. Let me go ahead and copy this down. I will copy this down here so that we can use this doubling time formula. Okay? So what's the doubling time going to be? That will be natural log of 2 divided by the rate of r. What is the rate? The rate is 0.039. So divide that by 0.039. And I will go ahead and say that is approximately, and we need a calculator, right? Let's go type this in. Natural log of 2 divided by 0.039. The doubling time is 17.77 years. So that is how you can solve question number 8 on your 2.1 homework. Should we keep on going? Yeah, why not? Let me go over number 9 in this same video, okay? All right, number 9, the price in dollars per unit that consumers are willing to pay for a popular high-end digital camera is given by the accompanying function, where X is in thousands of units. Complete part A and B. Okay. What's the price? What price corresponds to a demand of 380,000 units? Okay, so they gave us the X value, right? They gave us the X value. X is, well, listen, they did say X is in thousands of units, right? So X is not 380,000. I should just say X is 380 because X is in thousands of units. So let's just go ahead and say X is 380. They want to find the price. Simple problem, huh? Let's just plug it into the price function. So what is P of 380? I have to do 1680 minus 170 times natural log of 380. All right, now it's time for us to put that in the calculator to get the price. $16.80 minus 170 times natural log of 380. The price that the price that's corresponding to the demand of this many units of camera is $670.17. Okay. I bet they're going to ask us for the other way around. How many units will consumers buy at a price of $450 per camera? So this time we're going to have to plug in 450 on the other side of the equal sign because that's the price. And we're going to have to solve this for X. All right, let's use our solving equation skill. First, I will subtract both sides by 1680. All right, what is that going to be? I have to do 450 minus 1680. That is negative 1230. And that equals, this canceled out, minus 170 natural log of X. I need to get rid of this multiplying by negative 170. So let's divide both sides by negative 170. I wonder if it's going to be a nice number. So let me try. Negative 1230 divided by negative 170. That's not really a nice decimal. So I'm going to just try to convert it into a fraction so that I can use that, okay? That is 123 over 170. All right, I don't think I need a calculator for right now, so I'll bring this up. And that equals natural log of X. All right, we need to solve for X now, and we're not going to divide by natural log. We're going to rewrite this in exponential form, okay? All right, hold on. I'm going to have to rewrite this in exponential form. So base of a natural log expression is going to be E is E. So we have E raised to the 223 divided by 170. That equals X. All right. So let's go ahead and type what that is in a calculator to get an approximate answer. So what is X? X is going to be E raised to the 123 divided by 170. And that, I think I messed up something, you guys. I noticed something. And I've been recording for so long, I don't want to go back and redo it. Take a look. When I simplified this fraction, okay, I simplify this fraction by just getting rid of these zeros. All right? My silly self forgot to get rid of this 0 here. Oh, thank goodness I found that out. So it shouldn't be 170 in the denominator. It should be 17 in the denominator. Okay. I know if you were here in a classroom, you would have caught me like 2 steps ago, but I was by myself. Okay, so I need to type in e raised to the 123 divided by 17. Okay, so take a look. That comes out to be, I'm going to go ahead and write the number down. 1387.5488941. Okay, I'm going to write it down, but remember, x's are in thousands of units, right? X's are in thousands of units. So if x is, look, if x was 380, the actual number of unit was 380,000. So if x is this, what do we have to do to get the actual number of units? We must multiply by 100. I'm sorry, 1,000. Multiply by 1,000. Why do we have to do that? Because x is in thousands of units. So if you want the actual number of units, you need to multiply x by 1,000. So I'm going to just move the decimal place 1, 2, 3 to the right. So here's the answer. 1387.54, and you know what? The next number is 9. Let's go ahead and round that up to 9. So how do I read this number? Let me see. I'll go ahead and separate these a little bit and put some commas. So we have 1,387,549 units, and that is the answer for part B. It's not calculus, I don't think. It's a very good review unit, review section of solving and evaluating log equations, and this one was a doubling time exponential function. So hopefully these are helpful. I will come back and go over the last one, question 10, in my last video.